the 12th of August. It's 4:15 in the morning, recording this early so I can get a good forecast in here for Erin. Talk as much as possible about it. Give you all as much information as possible, the latest info. I know it's early, but it takes at least an hour to put all this stuff together, if not longer. So let's get started here. This is Erin. You can see it's struggling a little bit right now. This is the infrared. Let's see. Let's do the visible shortwave. You can see the visible is about ready to come up through here at first light, but you see a low level swirl here. Let me get my pen going. Sorry about that. Low level swirl plus the higher cloud tops, um, right to the right of it, to the east. Long wave IR. You see, I had some stronger convection earlier today, early overnight during the diurnal maximum, which is not unusual for storms of at this phase in development to do this pulsing, especially when there are marginal sea surface temps, sea surface temperatures, and moving as fast as they are. When they move more greater than like 20 knots to the west, they tend to um, not develop quite as fast. And given Erin's small size right now, it's going to be subject to pretty big fluctuations in intensity based on the slight changes to its environment until it gets over more favorable environmental conditions. Um, so, what are we looking at here as far as the model output goes? We'll go through all the ensembles and the operational models, which really, frankly, haven't changed a lot as far as intensity and track, which is quite unusual for um, models to not waffle so much as far out. But that's a good thing because it gives me more confidence on what's going to happen here. So this is the AEI models plus European ensemble and high res models. You see Erin out here. This is, see if I can get a more recent run. No, well, anyway, that's what I get for starting this early. So, tropical storm Erin out here. You have this low that has a possibility of developing, but 10%. Erin out here in the tropical Atlantic, moving to the west at 22 miles an hour, likely with a low level flow, and you have this disturbance of the coast not expected to develop just to bring heavy rainfall to the coast of the U.S. So going back to this plot here, you have the tracks along with the low centers. Most of the models want to bring it back to a tropical depression temporarily, which is not surprising. Most develop it into a hurricane once it reaches just before the Lesser Antilles. And then all these models, what it looks like, want to make it category 1, 2, or possibly 3 hurricane as it recurs out into the open Atlantic. It should be noted, however, that model guidance past this model spread is a lot greater and uncertainty is a lot greater as you get further out. So subtle changes in the overall flow pattern may dictate changes left or to the right, depending on changes to the large scale flow, high pressure, low pressure, things like that. So as you look at the European ensemble output, latest run, this is the European ensemble was part of the AI model suite here that I just showed you, but these are 31 members, excuse me, 51 members, almost with excellent agreement, except for a few outliers here of it being just north of the Western Antilles in 5 days, uh, and then moving it. Oops, a little bit challenging this morning. Moving northward, northwestward. That's where the model run stops. The European operational run, same thing, starts deepening it as it moves north of Lesser Antilles. And we go to the American model output, which is 31 members ensemble. Each number in here represents one of the model outputs. You can see most of them tightly clustered over the Lesser Antilles, moves north of the Bahamas, and thereafter model spread shows some going to the right, a few outliers going to the left, the majority are off the coast of the continental US. Some still want to bring it to the left, but most bring it out to sea, at least right now. And we'll go over what factors are driving that here in a minute. GFS, operational run, moves it out to sea as a strong Cat 2, Cat 3 hurricane. Pretty strong right there. Right near Bermuda, unfortunately, as of right now. We have to keep an eye on Bermuda too, which is right there. Right there. Oops. Yeah, so have to keep an eye on that. If we look at the European AI output, the latest model guidance on it, it's want to move the system offshore here. There's a strong system here, likely due to interaction of weakness in the subtropical high here on the east coast. And this model, just of note, later in the period, wants to bring another system here into the Caribbean, like the 26th of August, which is 14 days out, but we'll just have to see how that plays out. I hope that doesn't happen. Our biggest concern right now is, and this model doesn't want to bring it towards Bermuda as much, but that's still quite a ways out. We'll just have to see how that goes. Canadian has a low pressure off the coast of East Coast here. I'm not sure what that's all about, but that's not Erin. It's remarkable the agreement. They wants to develop that system out here too in the tropical, subtropical Atlantic, North Atlantic. Doesn't want to get it's quite as strong, but it takes it just to the west of Bermuda. Icon. I like to show all these models because Icon is pretty aggressive here. Wants to make it 928 here. That's pretty. That's Category 4 status. That's pretty strong. What I'm trying to say is that all these models are agreeing that something is going to be out here pretty strong um, in 7 days or so. And this isn't just me or Tim Ealer or some other YouTuber like Mitch West or Max Velocity saying this. I'm just going by the model guidance and what National Hurricane Center thinks. And I'll show you the rest of that here in a minute. But so that's that. And the environment surrounding this is what's driving this storm's motion. So the European AI, this is the 500 millibar mid-levels of the atmosphere steering flow HUD anomalies based on climatology. So the darker reds are high pressure systems, and the darker blues are lower than normal pressure. So you see high pressure. You can't really see where Erin is. We see it out here, right here. Moving along the low level flow. There's a low pressure out here, high pressure to its north, right? Moves to the north there. You have a low pressure out here developing in the central Atlantic. High pressure off the east coast. Low pressure developing up in Canada. Low pressure swinging eastward. High pressure that was over the shifts to the west here. Weakness is developing in the flow. The system feels this weakness. Feels this meaning it goes, stronger storms tend to curve to the right, especially as they get further north in latitude because they're more heavily influenced by upper level flow from the west. That's just the way it works. So anytime you have a weakness where you have low pressure building in, storms will move towards that low pressure to the right. So that's exactly what's happening here. See a high pressure building again to Erin's east. Erin moves towards, in his forecast, become a powerful extratropical cyclone with another system maybe developing in the Caribbean where this high pressure cell is right to the north of it in the long range. GFS, American model height analysis. A couple of low pressure centers here. You see this one over the over Canada. Again, it shows high pressure off the coast, east coast United States, subtropical high. Interestingly enough, the subtropical high is kind of suppressed over the open Atlantic here, at least according to this model. See the high, the GFS once developed this low over Canada. Once it maintained a little bit of a sliver of that ridge a little bit longer, but eventually same scenario plays out where it moves up into the weakness towards this extratropical low and merges with it in the long term, with a subtropical high being reestablished over the Atlantic Ocean at the end of the period. Oddly enough, the GFS doesn't really want to develop anything else out here in the long term. As far as the environment surrounding Erin right now, quite a bit of dry air. At the mid levels, but surrounded by moisture here moisture pocket moves with it as it moves over time. A little bit of dry air around it, but it manages to fend most of that off. And as it gets stronger, it tends to, especially as it gets over warmer water here, tends to want to really develop its own environment. Although there is some dry air to its west that may want to get entrained in the circulation, and it moves out into the North Atlantic. As far as wind shear goes, there is some wind shear to the north and to the south of this system, but you can see it has a high pressure over top of it for most of its life cycle, even though it's on the northern edge of it at some points here. This is where it really starts to intensify when it moves over the north of the Lesser Antilles, likely due to some positive interactions with upper level flow as a result of this trough and poleward flow and equatorward outflow, which helps evacuate mass from the system, which will help it intensify, at least temporarily. And that's not uncommon. You know, you have positive interactions before the shear really impacts the system, which allows it to intensify uh, when it reaches close to the mid latitudes. Again, this is the water vapor loop surrounding Erin. There's quite a bit of moisture around it right now. It's just struggling a little bit because of its fast westward movement. And it'll probably continue to pulse on and off and maybe weaken back to a depression before re-strengthening again as it gets further west. For our sea surface temps, we showed these yesterday. It's in the marginal area of sea surface temps right now, so that's one of the factors that is keeping it from doing much more than it is right now. So I'm going to go to the track forecast here. This is from Tomer Berg website, which is an excellent website. There's a lot with data that the National Hurricane Center presents too. But this is current intensity National Hurricane Center issued 1,004 millibars. Current is right near the 26C isotherm here. Moving to the west, forecast to keep moving to the west and then shift a little bit to the northwest, become a major hurricane north of the Lesser Antilles. So this is sea surface temp plot. And the models, especially the high res hurricane models, ingest these sea surface temps as part of their model input. So that's part of what's driving the intensity here. This is the Super-Ensemble output for Erin. This is the EPS, GFS, and CMC ensembles combined. What this is, just the three ensemble members and what it an overall thinking on the track. Pretty tightly clustered initially. You can see there's quite a bit of spread in the different deterministic models. Ensemble mean is in black. Quite a bit of spread as you get further out, which isn't unusual. This is 20 August, which is 8 days from now. This is ensemble mean trends, which is just showing the trends in the models over time. So the current trend is for it to go a little bit further south. That's probably going to change on and off just a little bit, depending on where its initial position is, how strong it is, and the impact on the flow on the system. This may be important as we get a little bit further down the road here, depending on where its initial position is. The track, like when the model initializes, how far south the track may be pushed. I don't see any models thinking it's going to go hit the lesser Antilles though. That's a really low confidence scenario. Model forecast tracks. These are all the global models, hurricane models. National Hurricane Center in black. National Hurricane Center guidance is on the northern end of most of the model guidance. You can see they're in really good agreement, even as we get north of Lesser Antilles. This is the GFS. This is the ensemble forecast tracks for Erin. Initialized 11 August 1800. This probably has changed a little bit, but GFS mean is in black. Deterministic, which is the operational run. And then you have the best track was in blue. You can't really see it here. And these are all the members. So weaker members likely further south because it follows a little flow. But if the Erin is strong enough to feel the upper level flow in the atmosphere, it'll likely move to the northwest. Low confidence that it'll move to the south here. This is only if the system stays very weak. These are the forecast and intensity tracks. You can see what I'm talking about here. Weaker members want to be pulled further south, and as Erin follows a low level flow, there are some members that do that, but this is low confidence right now. Most of them, you can see some want to really develop it a lot. Quite a few want to make it close to 950, 940 millibar, possibly Cat 3 or 4 hurricane. This is the rapid intensity model output. Intensification ships, which is one of the models the National Hurricane Center uses to determine if they think it's going to rapidly intensify. And it's based on a lot of factors: wind shear, sea surface temps, relative humidity at the mid levels. You can see right now it's at 60%, but it's forecast to get less for a while, and then it's going to increase over time. And so will the heat content. That's part of the SSTs. Wind shear is supposed to increase some, then decrease again. And you can see as a result of this, max potential intensity is 150 up to 160 knots. And so that's that. And you can see Cat 3 forecast rapid intensification probabilities through 65 to 72 hours, 23%. I think the chance of rapid intensification in the short term is low right now. And that's that. One thing I wanted to show you, which is kind of neat, is this is a microwave imagery simulation of the structure of Erin. See over time how it had more. This just shows intensity of the clouds, brightness. You see the structure of Erin is not that great right now with and based on the satellite imagery you would agree, but this is a good way to look to the inside of the storm, see structure here. Very good tool to have for forecasting. Last thing I wanted to show you was the uh, phase space diagram here. This is showing the lower tropospheric thermal wind with low tropospheric frontal nature, and helps predict if it's going to become symmetric warm core system. Obviously, you can see what's going to happen here. Current position A is where it was. C is current. Kind of a shallow system right now, but forecast to be symmetric warm core, deep warm core, almost off the charts here as far as the what this chart shows. This compares a low tropospheric thermal wind versus upper, which is just a way to determine if it's going to be warm core or cold core. Cold core systems are extratropical cyclones, deep warm core, or tropical cyclones. You can see what this is here. Sea surface temps longest track. We talked about that. Going to be moving over warmer temps over time here. And that's part of what's driving this intensity forecast. Anyway, that's all I have on the tropics for today. I'm going to try to get out a local forecast for the lower 48 if I have time today. But doing this tropical update takes quite a bit of time, so we'll see. Hope you all have a great day.